So we are live on YouTube. Let's give it a second. All right, guys. So thank you so much for joining another session, another live learning session. Today is going to be a build up on whatever we started on Friday. Okay, so I'm going to just share the YouTube link here so that anyone can join or watch from that side. All right, so we're going to continue on whatever we began on Friday. It's going to be quite extensive. It is important that you pay close attention to whatever we're going to do here. But as always, today I'm going to just dedicate just 5 minutes to just listen to anyone who wants to share their views or any questions with me before we move on. I don't want to waste so much time because we have a lot of ground to cover. So anyone wants to share with me any complications that they've been facing, any challenges that they've been facing, and so on. Anyone at all? All right. So hi Al Hassan. Hello, Al Hassan. Hi, Freddie. Okay, Al Hassan. I think I can sort of hear you now.
Hello.
Hi, Al Hassan Bawa. Okay. So Freddie, do you want to share? We just have like 5
Hi,
minutes.
Paul.
Hi, Freddie.
Yeah, I wanted to share on the one that
Since
we did
my network is giving me a problem.
Hi, Freddie. Can you please continue? I think Bawa is having some network challenges.
I was saying that I think my VS Code has a challenge of I don't know when I push and commit with the programs that I'm doing on the VS Code. It gives me a message that says permission is denied. If it's not permission is denied, another message comes.
Okay. Did you set your remote URL with your personal access token?
Did a new one, and when I push it, and it doesn't add. And the thing is, with the link that is there, I'm not really sure if I should copy it and paste it and use the print function. That's why I'm confused. I'm really confused.
Okay, so this is what you're going to do. I'm going to just use this file here. Okay, let's just use this one here. So you're going to generate your personal access token. Okay, so if you already have a personal access token, it would look something like this, right? Some random numbers like this. Okay, then you need to recreate or reform your GitHub URL, which will be in the form like this: https:// Then you need to copy your personal access token, paste it here, and then do at github.com / your GitHub username. So let's call your GitHub username Freddy. Okay, / the name of the repository. So let's call it ALX_Python. Okay. Once you create this, copy this, go to your source control. Okay. Let me just open the one with
cloning. That's the cloning process, right?
Come again.
Process.
Come again.
Process. Isn't that how I clone my repository to VS Code vis-a-vis the GitHub?
So after you clone your repository to VS Code, okay, there are a couple of options that you can use. Hold on, let me just find one. I think, was it this one that I used? Let me see. Right, I think this is it. Okay, so down here, when you go to the source control, okay, you click on this three dots. Scroll down to remote. Freddy, are you following? Then click remove remote. Okay, this will remove the remote URL. It will tell you it will ask you which remote URL do you want to remove. Then you just remove it. Does that make sense? Okay, so once you will remove it, then you need to add a new one, which will be the new one you've created. So you do the same approach, 3 dots, come to remote, go to add remote, then you paste that URL you copied in here, then you press enter, then you type origin here, then you press enter again. Is that okay?
Origin on top. I'm pasting the link with the personal access token up there, right? And I
Yeah, so
press enter.
exactly. Then once you press enter, I will ask you for a remote name. Then for the remote name, you just type origin. Is that okay?
Let me do it now.
Okay, so please do that. All right. All right, guys. Thank you so much. Freddie, if you have any other challenges, please reach out to me on Discord, and I'll be more than happy to assist you. Okay. All right. Great. So, guys, welcome once again to another session. Today we are going to continue on whatever we began on Python. Okay, so if you missed last week's session, I would highly recommend you go back to rewatch that session because it contains valuable information on the introduction to Python. So today we won't waste much time, and feel free to stop me or feel free to chime in at any moment to ask any question, but we are going to continue on our Python journey, okay? So last week we did touch a bit on, what is this? On how we can actually channel our outputs. Okay, hold on. So let me bring this one here. Let's see. Okay. So last week, we actually looked at how we can channel our outputs to the terminal, okay? We looked at how we can install Python on our PC, how we can create our Python files, how we can write a couple of Python codes, and how we can execute those codes on our terminal and then see the output. We also appreciated the fact that Python, unlike HTML and CSS, does not use the browser to provide you an output, okay? Python uses the terminal or the command prompt to actually display the output. So for example, in HTML, if you're using an H1 tag to see the output, Python, you wouldn't use an H1 tag. You would actually use or pipe your response that you want to see through the print function. And then when you execute by clicking on the play button here, you tend to see your output in the terminal or the console. We discussed on variable creation, and we spoke about variables being containers that we create. We actually create to store some kind of data, because as engineers or as software developers, we are going to be dealing with a lot of data. This data can come in the form of numbers. It can come in the form of words, sentences, music, videos, images, and the like, right? But we looked at the primitive ones. We looked at numbers, we looked at strings, we looked at booleans, we looked at some sequence types, being it lists, we looked at mapping types like dictionary, we looked at, why is this happening? Okay, we looked at tuples and the like, right? Then we also went further ahead to actually, please give me a second. Let me make this guy co-host. Okay, yes. Then we actually went further ahead to look at how we can create a couple of variables and how we can display the content that is held or that is stored in a variable on our terminal. We did a couple of these. Then we went further to actually look into how we can actually put together these variable creations to write simple and mini programs, right? So we wrote a program that calculated the discounts on some items, and in this case, it was a phone and then a game, and then we saw how that worked, right? Then we also embarked on a journey to look at some introduction to strings. Today, we are going to continue, but we are going to pay particular attention to some technologies or some mechanisms that you need to understand in Python. Okay, so we've done so much. We've created variables. We understand data types. We understand how to execute Python programs and so on. But then there is something in Python that you need to understand, which is the assignment operator, okay? Now, just before I move on to the assignment operator, I believe we have all encountered the projects on the intranet, and we've seen how confusing they might be, or we might have some questions in that light, right? Please, if you have any questions, please hold on and then ask me at the end of this session, okay? Great. So as we speak, we have looked at variable creation and we understood that variables are just containers, right? So we create containers that store some content for us. Those contents could be numbers, they could be strings, they could be booleans, they could be tuples, they could be lists, they could be dictionaries, There could even be a none type, right? But how then do we store content in the containers that we create? We leverage on something called the assignment operator. In Python, we use the equal to sign. This symbol that you see here is actually known as an assignment operator and not an equal to operator. Please take note, this is an assignment operator. So for example, if I want to create a container to hold first number, I can say first number, which will basically be a variable that I've created that I want to assign a number of 700 to. Okay, so now this in here is not an equal to symbol, but it's rather an assignment operator. So I'm assigning the value or the data type integer, right, of value 700 into a container called first number. I can do the same thing to second number, okay? Second number, as you can see here. And I can store some number like 900. I can also do maybe another container and say a pet name and say my pet name is called Rocky, okay? I can also say maybe let's say favorite food, and let me just say this is rice, okay? So basically all that you see me doing is I am just creating containers which are called variables, and I'm assigning using the mathematical equal to symbol, but in programming we don't call it equal to, it's called an assignment operator, then the value, okay? Maybe I can even assign a list and say maybe list of cars, okay, like this. And then I'll use the list operator, then I'll use, let's see, Ford. I can use Toyota, okay, Toyota, and so on, right? I can put any number. I can say list of students, okay, or learners, like this. And then say, okay, these are the list of learners, and I'm going to say this will be, I'm going to use Freddie, I'm going to use Philip, I'm going to use Amira, okay, and so on. So this is just me creating a container, all right? And then assigning a particular data type to that container, okay? So with that being said, we now understand that these containers that we've created actually reside in our computer's memory, okay? When we execute this, our computer's memory allocates space that actually stores these values for us. But that is a bit lower level, so let's take to the high level stuff. All right, so that is all about the assignment operator. There are a couple of assignment operators we're going to look at in the coming days, okay, as we actually explore and practice more on, let me just do this, okay. We'll practice and explore more using practical examples, okay? Sorry, I just got distracted for a second, but it's fine. Just trying to put things together here. Okay, good. So with that being said, we are going to look at the second part of it. Please, once again, feel free to stop me at any point, okay? Now, we actually looked at numbers. We looked at different types of numbers that we have. But then let's actually pay closer attention to the numbers. So before we go there, for all these containers that we have created here, okay, this is going to help us at the numbers, so I need to bring it in here. For all these containers, they are actually storing or containing some values that we need, okay? But if they are containing the values, can we see them? Yes, we can. That is where we use the print function, and then we use the name of the container that we created. And in this case, I want to see first number. So by passing the name of the container in here, the print function is going to dig into the container, pull out the content that is stored in the first number container. So if I press on the play button here, I am going to see my output down here. So I guess I have some print here that I have to comment out. I need to clear my screen, and then I need to run the code again. So now you see, we can see the first number being 700. Okay, what if I want to see the name of my favorite pet, right? So I can say my pet's name. There's a container that I have created that always stores my pet's name. So if I execute this, I see my pet name executed or printed to the console. Okay, great. This is great stuff, right? But they are very basic. Very basic in that we need to know these things in order for us to be able to write bigger programs. So the next thing we're going to look at is numbers, okay? Numbers. Now, from last week's session, we actually looked at numbers. We looked at different types of numbers. But we want to focus a bit more on Python numbers, okay? So in Python numbers, we have three basic ones, right? The integers, the floating point numbers, and then the complex numbers, okay? So I'm going to create a number here, and I'm going to store 56 in here, or assign 56 as a value in there. Sorry, 56 as a value in here. Then I'm going to create another number. Let's call this number 2, okay? And I'm going to store like 10 in here. Okay, these are integer values. Integers, as by definition, are negative and positive whole numbers, right? So that means I can store, let's say, remainder, and say this is negative 45. I can also serve another number and say, let's say, num, and say this is negative 467. I can also even use x and say x is 334. I can use y and say y is 78. These are all numbers, integer numbers that we can use in Python. If we want to validate or confirm the type of numbers that these are, we can use the type function, okay? So I'm going to say type of number, okay? Create a variable called the type of number. Then I'm going to use the type method and pass number in there, okay? So now in here, I have created a container that is going to store the type of data type this variable number is, okay? So if I print this out, type of number here, and then I execute, it's going to tell me it's a class integer. You can see that here, right? Class integer. I hope you can see it clearly. Maybe, no, this is too big. I guess this should be better, okay? So you see class integer in there. So if I run it again, you see class integer. So what if we want to check the type of remainder, okay? Remainder is also another container we have up here. And I think this is not too good, okay? So remainder is a variable that we have up here. So if we want to check the type of data that is stored in there, we can just use the type function, store the output, or save the output in another container called type of number, and then print that output to the console. If I execute this, I get integer, right? So you know that integers are negative and positive whole numbers. So even negative 45 is an integer, right? So these are integer numbers, okay? So you can use any integer number that you want, integers, in Python. As well, there are floating point numbers, okay? Floating numbers. So now, what are floating numbers? So let's declare another variable. Let's call this variable height, okay? Now, height is going to be 6.5, okay? So if I check the type of variable or the type of data that is stored in the variable height, let's see what it tells me. I'm going to save and I'm going to run, and it tells me it's a floating point number. Now, we need to understand something here, guys. We are doing this because these containers are just regular containers. You can put anything that you want in them. For example, if at any point in time, I check the type of content that is stored in number, okay, in this particular program, and I execute this, it will tell me it's an integer. But there's something called declaration or reinitialization, okay? I can reinitialize number here again, but this time I'm going to put 78.90 in here. So if I should print the type of number or the type of data that is stored in this container, what do you think it would be, Amira?
Hi, I think it would be, hi, hello everyone. I think it will be a float because it's after the first one.
Exactly. So because we have reinitialized, initially when we initialized number here, it was an integer type. But when we reinitialized it in here and we are printing it down here, okay, it would be a float. So let's try that. And now we see we have a floating point number here. But if we should print that same number here, print and put type, okay, and then put number here. The same thing, this would give us an integer and this will give us a float. So if you run this, we see the first one is an integer, the second one is a float. So it makes us appreciate and know the type of data that we are working with, right? So let's pay particular attention to that. Now, floating point numbers can be any number, right? So let's try another one. Let's try x. Now this time, let's try negative 556.78. Okay. And then let's check what type of data is stored in X. If we execute this, it will tell us it's a float. So floating point numbers also, we can also have negative floating point numbers, right? But now, what if I have X here again, and this time I'm going to type 5J, okay, 5J. Now, if I print the type of data that is stored in S, who can guess? What type of data do you think this would be? So that would be a complex number, okay? So it's a complex number. So one thing we need to understand that these are all data types that we can use in Python. We have looked at them extensively, and it's something that we need to pay particular attention to. If you are dealing with numbers, if you are dealing with computations, if you are dealing with anything that has numbers in them, you are going to be dealing with either an integer type of number, a floating point of number, or a complex number, okay? Now, numbers. What can we do with numbers? Hi, Freddie. Assuming I have two variables, okay? Freddie. Assuming I have two variables, num1 like this, 50, and num2 like this, 70. Freddie, what do you think I can do with these two numbers?
And 70.
We have what?
You can put it in. You put them in a container.
So they are in a container. So each and every one of them exists in the container now. So what operations do you think we can perform on these numbers?
The type operation, I'm guessing myself out.
Okay, that is right. But let's also take Simelo. Hi, Simelo. What other operation do you think we can perform on this?
We can find the sum of the numbers.
Okay, so good. So we can find the sum, right? So we can perform addition on these two numbers. What else do you think we can perform on this? Hi, Miriam. Hi, Miriam.
You can find the difference.
We can find the difference. Marianne, Okoyi, what else do you think we can do?
You can divide them.
We can divide them. Hi, Fred.
Multiply.
We can multiply them and so on, right? So all those operations that you guys just mentioned are what we call the arithmetic operators, okay? The arithmetic operators. These arithmetic operators exist in mathematics, but we also need them in programming. Why? Because we will be dealing with a lot of numbers, and we will be dealing with what? A lot of operations. So some of the operations that we can perform are addition, okay, subtraction, multiplication, as you said, division, but also we can perform a modulo, okay, operation. We can also find the exponent of a number, and we can even find the floor of a number, okay? So let's take a look at this. So if I take these two numbers, I can find what? The sum of them. So I can say num1 plus num2, right? This is a valid operation that I can do. So I can print this, yes, sum, and then let's just comment this out. If I execute this, it will give me 120. That is the sum of those two numbers, right? I can as well find the difference, right? I can find the difference by saying num1 less num2, okay? It could be any other that I want. So I can check the difference in that number, and it gives me a different output every time. You see that here? Negative 120. I can as well find the product, right? Which will be num1 times num2. I think I need to move this. Okay. Num2, which will be the product. So I can actually find the product, right? Now, if I run this code, I get the product of both of them. I can even divide them, right? So I can divide, let's say we want the quotients. Okay, so which will be num1 divided by num2, okay? So we can find the quotients here when we divide the two numbers, and then we get the number answer here. Do you see that? We can also find the remainder, okay? We want to divide, but we don't care about the quotients. We care about the remainder. So let's say we can pick num1, and then we can say if you divide num1 by 3, what will be the remainder? Okay, what will be the remainder? So we can check that here, remainder. So I'm going to execute this, and it tells me the remainder is 2. So I want you to pay particular attention to this. In programming, division and modulo are 2 different things, okay? Many people confuse this fact. When you divide 2 numbers, you care about the quotient. Is that okay? You care about the quotient. But when you find the modulo of a number, you don't care about the quotient. Both of them use the same method and the same operation, but the results are different. The division operation cares about the quotient. The modulo operation cares about the remainder. Okay, great. And then we also have exponents, so we can find the exponents, right? So let's take a simple number, exponent of 2 raised to the power 2, okay? 2 exponents 2, right? What do you think we'll get here? That will be 4, okay? Maybe we want to find 2 raised to the power 2, 56, right? 56. What would that be? And then we have that number here. Do you see that here? So we can easily do exponents and all that in Python, okay? It's so easy, you just need to know the annotations to use. Then there's the floor operator, okay? So let's find the floor. So maybe I have let's pick 2 random numbers. So let's say 3.5 floor, okay? So if I do this, it is going to give me it's going to give me the lowest number, you see that, and so on. So these are all arithmetic operations that can be performed on numbers. As you've seen now, I have performed these arithmetic operations on integers. They can be performed on floating point numbers, and then they can be performed on complex numbers to an extent. You need to understand math to a particular level to be able to do complex number multiplication and all that, okay? But for the basic ones, integers and floating point numbers, you can perform arithmetic operations on them, okay? You can perform arithmetic operations on them. Any questions up until this point before we move on? Any questions up until this point?
Hello.
Hi.
Yes, Bawa.
Hi,
please, please ask, why didn't you use divide instead of quotient?
Okay, so in here on line 30, right?
Yes, please.
So divide is the operation, okay? But when you are dividing a number, you get multiple parts, okay? So for example, if I pick, let's say, num1 divided by num2, num1 is the dividend, right? Then num2 is the divider. But the output, the result will be the quotient.
The quotient.
Do you understand? Okay. Good. Yeah. That is why you need to know that. In programming, you need to be very concise. If you are not concise with your wordings and your operations, you might get it wrong. That is why I didn't put divide here, but I put quotient, because the output that we are expecting is a quotient.
Okay.
Is that okay?
Please, what of the floor? The floor, is it that it means it gives the least common multiple?
No, the floor gives you the nearest whole number for the results. Okay. This one here, you need to look at it a bit closer, but we are not going to do that because we will do that later in future. Okay, but for now, you just need to know that there exists an operation called the floor. There's another one called the ceiling operator. Okay. These are all operations that we use in math. Okay. They will come in very handy as you write complex programs. Hi, Miriam.
Oh, I wanted to ask about the floor, but you explained it.
Okay. All right. Hi, Philip. Hi, Philip.
Okay. If I may ask,
yeah.
Does the floor mean that it discounts the remainder?
No. So the floor will now give you an output. So let's say if you divide, let's say, let me use this. If you divide 3 by 2, what will be your answer? What will be the quotient? Hi, Philip.
Hello.
Hi, Philip. So if you divide 3 by 2, you get what? 1.5, right?
1.5, yes.
But if you find the floor, it will give you the nearest whole number of 1.5. So
Which
now
is...
see that if I run this code now, I'll get 1. That is the nearest whole number of 1.5.
Okay.
Do you understand?
Yeah. Why would it?
All right.
Why would it not give 2?
So that would be the ceiling operator. Okay. All right. All right. It's actually an interesting operator, so you can look into it. Hi, Shima.
Cool.
Hi, Shima.
Hello. Hello.
Hi, Shima.
Can you hear me?
Yeah, I can hear you.
Yeah, I wanted to know the real difference between those exponential sign of two times, okay?
Okay. So
And
you want to know the difference between this?
Between this and another one of the power, the one which looks upside. I don't know how I can call it.
Wait, show me the line.
No, it's not there.
Wait. You mean this? You mean the carat symbol? This one here?
Yeah, that's one.
Yeah, okay, good. So the carat symbol is just a representation here in Python. So this carat symbol actually means 2 raised to the power 2, or 2 exponents 2, right?
Yeah.
But we don't use the carat symbol in Python, so we use the double star to represent the carat symbol.
All right.
Okay, all right, great. Okay, so let's move on, right? We have a lot to cover. Okay, so now we have a fair idea of this. So now we're going to move to the next topic, which is casting. Casting, what is casting? So sometimes when you are writing programs, you might want to convert one data type to another data type. For example, Amira, if I ask you, what type of data is this? What would that be, Amira?
This is an integer.
An integer. And what type of data would this be?
A string, I think.
Exactly. So you see, in as much as we know the physical representation of this value is 2, which is an integer, in programming, by just wrapping this 2 around with this, it becomes a string. It is no longer an integer. Are we all okay? Yes. So sometimes you want to convert your data from one type to another. A typical example will be this. So I'm going to write a simple program that will request or ask the user to input 2 numbers, okay? So I'll create a number 1 here and say use the input function and then ask the user enter first number, okay, like this. Now I'm going to create a second container number 2, and I'm going to use the same input function and say enter second number, okay? Now, ideally, if I print number 1, it is going to give me an output, right? So let's execute the code. So first of all, I'm going to clear the outputs, bring this up a bit so you can see, and then I'm going to execute. You realize when I run this script, it's asking me to enter first number. It would not continue executing until I enter the first number. So this time I'm going to enter 5, okay? Enter. Now it asks me to enter a second number. So I'm going to enter 10. Now you see the output on line 7 is 5. So now let's use our type function to see what type of data is stored in a number, okay? So we're going to do this again. This time we're going to run it, and then we're going to use 5. Oh, sorry, not you there. Here, we're going to put 5, and we're going to put 10 again. Do you see? We inputted 5, but the type is telling us that this is a string. Do you see that? So if we try to actually do a computation with this and say sum is equal to number 1 plus number 2, which is the value that will be stored in both of them, and then we try to print the sum, okay? This is what will happen. Look at this. Oh, sorry. Okay. So if I execute this, let me clear the console, and then let me just run again. I'm going to put 5. I'm going to put 10. Do you see that? It gives me 5, 10. Is that correct?
No.
Exactly. It is not correct. That is because it is doing what we call concatenation. Okay. So for me to actually perform an arithmetic operation, I need to typecast or convert this from a string to an integer. So whatever that is contained in number 1, I'm going to use the integer function to convert it from a string to an integer. Then I'm going to do the same thing for this here. Okay, like this. Now you'll see the answer would be different. If I execute the script again and I put 5, and then 10, the answer becomes 15.
Yes.
Do you see that?
Yes.
So it takes me back to the question that I asked Amira, that what is the difference between 2 and then this 2? One of which is a string and one is an integer. You cannot perform arithmetic operation on strings. You can only perform arithmetic operations on numbers and floating point numbers, right? That is integers, floating point numbers, and complex numbers. You cannot perform arithmetic operations on strings. The very moment you try performing arithmetic operation on string, it becomes a concatenation. Hi, Prudence. Hi, Prudence.
Hello.
Hi.
Hello.
Hi.
What is online? How we
Prudence, can you speak up a bit?
Is it possible to add in front of?
Prudence, I can't hear you. Is it possible for you to type your question on the chat for me, please? Okay.
Okay.
All right. Thank you. All right. Great. So as you can see here, these are some of the casting functions that we have in Python. We have the integer function where you pass the container or the value to it, and then it will convert it to an integer. So now look at this. I am now going to typecast this to a float. Okay. Then I want to show you the difference. Okay. Like this. Now I have typecasted both of them to floats, right? Now you can see this is 15. If I run the script again, same numbers, 5 and then 10. Now you see the answer is 15.0. Do you see that? 15.0 is actually different from 15. This number here is a float. This number here is an integer. So please take note of those differences. Okay, great. As well, you can convert the numbers to a string. So just as I showed you initially. Okay, so this is all about typecasting. It is important. It's an important tool that you need to understand in Python. So please keep that in mind. Do you have any questions up until this point before we move to strings? We have a lot to cover in strings. Hi guys. Any questions on here? Okay, great. If there are no questions, we're going to move on to strings. What we've seen us do so far is we are exploring like the units of Python programming, okay? And we're going to put all of that together coming soon, okay? And you've already started even in your projects. So now let's look at strings. What is a string? A string basically is a collection of characters. So for example, if I put COLE here, COLE is my name, but it is made up of characters, C, O, L, and E. Okay, so a concatenation of characters forms a string. It could be regular characters, it could be alphanumeric, it could contain weird characters, and so on. So long as it is a group of characters that you've put together, it becomes a string. Now, in Python, there are a couple of ways that you can define strings. That makes it different from numbers, as we have seen a moment ago. So we can use the double quotes to create strings. So for example, I'm going to write pet, and we all know pet name as a string, right? So I use the double quotes to represent a pet. So this time I'm going to call this Robbie. Let's do Robbie, not Ruby. Now this should be IE. Okay, Ruby. Now we can also use Lena1, okay, and say this is Lena1, and we're going to say Lena1 will be, let's call this Prudence, okay? Prudence. Okay, these are strings. Maybe we want password, okay? So password can be, let's put a password, and let me give you my password, tomatoes, okay, at this, this, and then let's put that and dollar symbol. So you see, this as well as a string. So anything at all that we wrap around with these double quotes are strings, right? We can actually test this to see using our type function. You can say type and say password, and it's going to tell us the type of data that password container is storing. Okay, so if we execute this script, and I'm going to clear the console, execute the script, I see it's a string. So basically, anything that you wrap around with this double quote is a string. But there is a problem. Sometimes you want your strings to be extremely long, like it could be a full character, right? So for example, I have some questions here that we're going to solve in a second. If I should pick this question, come here, it is a string, okay? So I can create question 1 and say this is a string and then paste this in here. Now, immediately you see the challenge that I'm having. It is going so far to the end, right? It doesn't make it very convenient. Even though it is okay, it would work fine. Look at this. I can print the question 1, execute the script, and you see the question printed down here. Okay, but there is a better way we can do that. So let's see that in a second. Just as we have used the double quotes to create strings, we can also use single quotes to do same. So we can use name here with single quotes and say, cool, do. We can use profession as a container, and I'm going to store, let's say, software engineer. Okay, oh, sorry, I'm actually an application script engineer, but it's fine. Okay, we can say location, which is also a string. Okay, and I'm going to say Accra. Okay, then maybe I'm going to use my height, but this time I'm going to be a bit disruptive, right? I'm going to say I am 7 feet 5 inches, like this. You see that? So immediately I am creating multiple types of strings. So think of any type of string that comes to mind, and you can create it using the single quote and the double quotes. Okay, let's print out my height here and see what it is. So in here, we're going to close this. Oh, is it? Oh. Okay, let the screen, and I'm going to execute this. So you see, this is my height, 7 feet 5 inches. Guys, I'm not that tall, okay? This is just an example, right? So anything that you can think in terms of strings or a combination of characters, you can represent as a string. But then I said there was an issue. And what was the issue? The issue was that if you have an extremely long string like this, it can be quite uncomfortable to use this. Okay, so Python gives you a different way to create a string, which is using the triple double quotes, right? So in here, I can say question, but instead of using the double quotes, I'm going to use 6 of them, okay, like this. So let's do it again. So you just do this, and then it comes. Now, if I do this, I can just expand it and then paste this, set, and then I'm going to get this, okay? So now you would realize that this is much more easier because I can actually format it in any way that I want. I can also say answer here. And then when I print this question, okay, let's just comment out my height. It is going to show the same way that I formatted it. You see the space that I placed here is going to show the same thing. Let me just bring this back a bit, run the scripts, and then you see it went back a bit. Let me take this to the beginning, okay, like this. I print it, and then you see whichever way you format your string in these codes would be the same in Python. So it is important that you take note of this, okay? Now, the same thing can be done for the triple single quotes, okay? The triple single quotes. Any questions up until this point? So I'm just going to copy this, and I'm just going to represent this here with a triple single quotes, right? Like this. And then here. But you would note something. You remember I told you about multi-line comments. In Python, if you use just this in your code without assigning it to any variable, it is treated as a comment, okay, like this. It is treated as a comment. So it's multi-purpose. You can use it to assign a string, or you can use it as a multi-line comment. Okay, those are just semantics. So please take note of that. Any question up until this point before we move on to the next ones?
Hello, Cole. I have a question.
Hi, not Caught. I think
you
wanted to speak earlier. Hi, Not. I think you wanted to speak earlier on, right?
Yeah, but I think I'll just research on that question. So just
No,
when you
so you
use
can
it,
ask.
okay, those double during that what they call it? Is it variables or addition? Yeah, the number
numbers.
33, that floor. Can you please? I don't want to. I'm not planning to like take class backwards, but what's that double line? What does it recalculate?
Okay, so as I said, if you divide 3 by 2, what will be your answer?
1.5.
1.5. So the floor will give you the nearest whole number, which will be 1. Okay.
1.
No.
1. Okay.
No. So there are two types of operation. There's the floor operator and then there's the ceiling operator. So I want you to research on them. Okay. So the ceiling would have given you 2. The floor will give you 1. Okay. It will come in very handy. I'll show you a practical way to use this. Okay.
All right. Next question that I want to ask again. That's back on the one you're working on right now. I'm having an issue actually. Okay. When I'm trying to run the code, I'm unable to run the Python. That's just the issue I'm having. So after typing the command, what's the next thing I click on? I have the Python installed already.
Do you see this icon? Do you see this icon on your VS Code?
I can't see it.
You can't see it. Okay. So the easiest way you can run it is if have you created a folder like this?
Yes, I have the folder already.
Okay. So now from your VS Code, just click on terminal and then new terminal.
Okay, terminal. Okay. New terminal. Okay.
Have you seen it? It should open something below your screen.
Yes.
Now, what is the last string that you see here? What do you see there?
On my own terminal, it's showing me the name of the folder.
The name of the folder, good. So the file that you've created, is it in that folder?
Yes, it's in the folder. Okay,
so type Python and then the name of the file. In this case, I'll do 5-string like this. Okay. So mine does not exist there. Mine exists in the Python. So yours will be a bit different. So yours will be 5-string like this. If you run it, you should get the same output.
Okay. Python.
Okay. Then the name of the file.
Okay. Then name of the file.
But it's much easier, as Shima has suggested on the chat, for you to install the extension. Okay. So install the code runner extension and then you'll be fine. You see this icon.
All right, let me install that right now. I'll see this. Okay. All right, thank you so much, Cole.
Okay. As well, hold on, North. You can also right click on the file like this and then look for run. You see run Python.
Okay, I'll click on the file. Please, can you go back to where you clicked? Let me see. Okay.
So the Python file that you are working on, right?
Okay.
When you right click on it, do you see run Python?
No, I'm not seeing run Python. I'm only seeing split left, split down, close part, copy parts, patch related, reopen editor with. I'm not seeing run.
So that means you need to install the extension, okay? The extension called code runner. Okay. So just check the chat. Is that okay?
All right. Thank you so much.
All right, you're welcome. Hi, Henry.
Oh, did I raise my hand? No, sorry. I don't know.
Okay, you are muted. All right. Okay. So we'll move on, right? So we are going to look at position in string, character positions in string. So as I was saying, my name is a string and it's called Cole, right? But from earlier on, I told you that every string is just a combination or a concatenation of characters. So if you are concatenating characters, and let's say if I put 1, 2, Beidou, and then 7, 8 here, I can identify the position of each character in the string. So Henry, if you're here, hi Henry, what would you say is the position of C?
C is 0.
Good. So Henry, you are right, but you're not entirely right. The question was position.
Oh,
okay. So there's a difference. So there's a difference between position and there's a difference between position and index. So let's do versus index. Okay. Like this. So Henry, what you gave me was the index of code, but it exists in position 1. Henry, is that okay?
I thought we never have 0 in code. We never have start from 1 in code, except from behind.
No. Good. So that is what I'm telling you. So we have position and index. We don't have 1 in index. Okay, the position is 1. It starts from the first position. Okay, there's a difference between position and index. The index is 0, but the position is 1. Does it make sense?
Yeah, it makes sense.
Yeah, so the position is where this exists in this string, but the index is how it's arranged. So what is the index? So in programming, we use index 0, but the position actually starts from 1. Okay, good. So call is at position 1, but what is 8? What is the position of 8? Henry, you again. What is the position of 8?
We have to start counting. 1, 2, 3,
okay,
4, 5, 6.
So let's go. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's at 13. Position 13, right?
Yeah.
Good. So we now understand that strings contains positions. But the way strings are arranged, we access them. We can access each and every position using the index. So we say the first one is at index 0. So if I want to print, I can say print, and I'm going to use name.get, okay? Get what? The index is 0, okay? If I do this, I'm going to clear my screen, and I'm going to execute this. Oh, okay. All right. Sorry, I'm using a different language. All right. So we're going to use 0 here, the 0 notation, okay? So if I use 0 here, that is the index. It refers to the index of C, not the position. So the index is 0, but the position is 1, okay? So if I execute this, now I have C. Then when we counted, this was 13, so this will be 12. If I execute this, it should give me 7. Okay, so this is 13. Save, execute, and now we have 8. Okay, so it follows in a chronological order. The first character is at index 0, 1, 2, 3, 4, 5, 6, and so on. So we can use indexes to actually print each and every character in a string.
So can we print with the position?
So if you want to print with the position, then you need to do some computation. So if you want the first position, then it will have to be 1 minus 1. Okay, because the first position is 1, is like the position less 1 to give you the index. So this will actually give me C. Do you see that? If I use the second position, then I just have to subtract 1 from it. Then I now get O. So the second position is O. The third position, I now have to subtract 1 from it to get L. Do you see that? It follows in that order. Okay, so you can use the position to get the character, but you need to subtract 1 to get its index. Okay, so you use the index to access the character. Okay, great. So those are the indexes and the positions in a string. Now, using these same indexes and position, we can do some quite amazing things. Okay, we can do amazing things. One of which is we can slice. Okay, we can slice the string. So for example, if I want to get, let's use, we're going to use name still. So print, we're going to comment this out. And then we're going to say name. We use the same square notations. We use the slice operator. That is the slice operator, the colon. Guys, please pay attention. If we put the slice operator here, this slice operator accepts something. And those things are a range, okay? A starting index and then an end index. So whatever is on the left side of this column is the starting index, and whatever is at the right hand is the end index. Okay? So let's try this. If I just put this without any numbers and I execute, save, and execute this, I get the full name, okay? Now, what if I put 1 here and I put 5 here? Let's see what happens. If I execute this and I'm telling it to start from what? Index 1 down to index 4. Okay, so 0, 1 is index, O is index 1, 2, 3, 4. Do you see that? It never adds the actual number to the end index. I'm going to give you the moment for you to ask a question here. When you are slicing a string, the start index always tells tells Python where it should start from. So for example, if I want to start from 0, it would start from index 0 down to index 4. So if I execute this string, I'll get COLE1. So 0, 1, 2, 3, 4. It doesn't include 5 as the position. It's going to use 4, which will be the index. Okay. If I want to just get code, I know the last position here is what? 1, 2, 3, 4, 5, right? So I'll just use 4 here to get the index of the last one, and now I just have code. So you see how easy it is for me to slice this? I can even say, you know what? I want to ignore everything, right? Code, and then just get 1, 2 Beidou. So I just start from this. Sorry, I'll start from 5 to the end. So if I run this, it's going to give me 4 to the end, right? If I run this, it's going to give me 1, 2 Beidou, because it's going to start from index 0, 1, 2, 3, 4, index 4. You see that? 0, 1, 2, 3, 4. So it's starting from index 4 down to the end. But if I want to come up to this side, then maybe I can say, I don't want to do that. So let's just count. So this is index 4, 5, 6, 7, 8, 9, 10, 11. So let's put here 12. If I run this, it is going to give me 1, 2 Beidou. If I just want Beidou, then I want to know the index of 2, right? Or the index of B, where it should start from. So 0, 1, 2, 3, 4, 5, 6, right? So let's put index 6 here, run this, and it's going to give me Beidou. So you see how I'm able to easily slice from the string that I have. It is a full string, but I'm just cutting part of the strings that I need to do whatever I want. Okay, so you can use the starting index to start from somewhere to the end index. Once again, index, okay? You can also ignore the start, and then it's going to start from 0 to wherever you specify that it should end. Okay, good. You can also choose to ignore the end, and it will go down to it gets the end of the string. All right, these are slicing in Python. But as well, you can use negative numbers as well, which will do it in the opposite direction. Okay, so please look into that. Any questions up until this point? All right, so let's move on. So we're going to do string modification. This is going to be the is. Hi.
Hi, sorry, please.
Hi,
sorry to cut it short. Okay.
No
please,
worries.
can you explain the second part again? You said it starts at the starting index and then the next one. I still
The
don't
next one is
get
is the end. So let's say I want to get just code from this string, right? So code starts from 0, right? So the starting index will be 0, okay? Or I can choose to ignore it because it will still start from 0. Then I need to know where do I want to end. So if I start counting the index, code is 0, 1, 2, 3. So E is at 3, right? So the end index here will be 4. If I put 4 here, that means it should come up to code. So if I run this, I would get the entire code. Okay. Right. Hi, Victor.
Hi, cool. Please, for the negative and slicing, you say we can slice it negatively. Are we supposed to start from +1, or we are supposed to start from 0 for the negative?
So Victor, come on. You have negative 0. We don't want to do
like 0.
Math here.
0 is from 0, -1, -2, -3, -4.
Yeah.
If you are
so you start from -1. Okay. -1 will actually bring you from the end. So if I go to -1 to, let's say, -5, like this, it is going to start from the end here and then bring me down here. Okay. So if I execute this here, you see, sorry. Right. So I need to clear the screen. Okay. So if we run this, it gives me just 8, because that 8 is the last one. Okay. So if I start from -2, it would start from 7, right? So it start giving me 7, 8. So if I put 5, then it's going to start from where? D, right? So it just keeps going the opposite direction. Okay. All right. So I want to cover all these things here. So let's move forward a bit. So then there's modification. So this one is going to be quite easy. So we can just convert my name. So let's just comment this out. Okay. So we're going to convert my name dot upper here to uppercase like this. Now take note of the way I have done this. I use the dot notation plus the name of the method, right? So if I execute this now, code becomes all caps. Then I can do dot lower, okay, like this. Then now everything becomes all smaller letters, right? I can also choose to replace, okay, let's say 1 with, let's put space, okay, or let's do 12 with space. If I do this, you see, oh, sorry, right? So now you see it replaced the 1, 2 with a space, okay, in here. You can replace any character that you want in there, okay? I can even replace B with, let's say, sorry, big B. I guess it's big B with, let's say, a star, okay? You can replace any format that you want, okay, that you want to do, right? There's also the split operator that actually, okay, so we're going to do print, going to do name dot split, okay? Now, if you split, you need to split it by a type. So if you just do this, right, it's going to be an empty separator, right? But if I put a space here, it's just going to give me the same name, but there are no spaces in there. So if assuming I should put a space here, put a space here, put a space here, the space here. So now look at what happens. If I execute this, it now splits it into code 1, 2, B, 78, and an empty string. Okay, so it just returns a list of the splitted value. Okay, then there's the capitalize. Okay, so we can just say we can print here. We're going to put Victor like this, and then we're going to say capitalize, and then what you realize is it is going to capitalize the V in Victor. So if you want to capitalize the first word in any string, you can just use the capitalize method and it will do that for you. Then there's also counts, right? So there's counts. So a count basically just, let's use name dot counts, and then count here is going to accept a string. So let's count C, right? The number of C's that we have in there. Okay, so it tells me there's 0 C's. But what about capital C? It tells me there's 1. So you can count any number of characters that exist in here. So if I take this question here, and I want to count the number of spaces, empty spaces that exist in there, it will tell me there are 56 empty spaces in there, okay? If I want to count the number of I's that exist in that string, it can actually tell me there are 7 I's in that string. So you see how easy Python makes life. There are so many more that you can actually explore. Okay. Now the next one is string concatenation, which we've already seen. Sometimes you have a string like Paul, and then you have your last name like Beidou. Okay. And you just want to put them together as full name, right? Like this. So you can do first name, use the plus. We've already looked at this, space, and then put the last name. So essentially what this will do is it's just going to concatenate the strings together. It will not perform an arithmetic operation. Okay, so this will be full name, like this, with parents here, and then we have Kobe, okay? But we can also do with formatting, okay? Even you can even choose to add your age, right? But look at this, 56. So if I try to add 56 to this age here, okay, and I execute, you see, it tells me I cannot concatenate an integer to this string because it's seeing this data type here as a number and it's trying to do an arithmetic operation. So we need to typecast this to a string, and then that will make life much easier for us. Now we have Obedu 56. Okay, great. We can also use formatting. We can format strings, okay? So we can actually say print, and then let's say we want to print my full name. So I can say use placeholders like this, okay? And I'm using the F string, okay? When you want to use the format string, you can use F string here. Then you put this curly brace here, and then you can just put first name, okay? And then you can do last name as well, like this. And it's just going to replace whatever is in this placeholder or curly brace with the variable name. Okay, if I print this, you see it gives me code Beidou. So I can even put anything that I want here, and it's still going to work. It makes life much easier. But also there is another one for the format method, like this format, okay, that allows you to pass the argument that you want to display, or the variables you want to display as arguments. So like this, but in here you need to create empty placeholders like this, okay. So if I run this again, I should get the same outputs twice, right? So let's comment this one here, comment this one out here, okay. So I'm going to do this, and you have that there. Now, one good thing about this is that you can actually give it positions, okay? So now it's telling me that 2 is out of range. So this has to be 0, this has to be 1, okay? If you run this, it's going to give me code, but as well, I can choose to say, I want 1 to come before 0, okay? Then now you have Beidou code. Do you see that? So this is actually cool. You can actually use this for your string format. Okay, great. Last but not the least, for escape, we are going to look at quite a number of things. Like, let's just take one. So for example, if I have my hi, come in.
Hello, please,
Hi.
can I ask this question? When you go to line 63.
Okay.
Yes,
I'm here.
See, full name is equal to first name plus, you see the quoted over the plus the last name.
Yeah.
And plus I was expecting that you can also bring quote over the plus.
Yes. Yes. So
that
is like formatting. That. Yes, you can do that like that. It's whatever you want to do, you can do it.
Then you understand? Okay. Then you remove the strings.
You want me to remove this? Yeah. And then print this, right?
Can it be possible like that?
Why ask? Why not do it? Okay, so just see.
And that's what
you see, it'll still not work. You understand? So you just the trick is to convert to typecast the data here, which is an integer, to a string. Okay. Great. All right. So for this sentence here, we want to say Johnny John's, okay, like this. Car. Now you realize that if you type something like this, already I told you that this is used to represent a string. So if you type something like this, it won't work. You need to escape the quotes using the /. So anything at all that you want to escape, you need to use the / to actually escape it before you can see it or have access to it. Okay, so like sentence here, we execute, and now you have Johnny's car. If I had not used the escape, I would have gotten an error because it would tell me that unterminated string literal. Okay, so it is important that you always escape some of the characters. Okay, maybe you even want to put a / here. Okay, if I run this one here, you see, I have this one here. If you use the single quotes, you could have also used an escape character to escape it. So basically, you use the / here to escape characters. Okay, and you're going to see a lot of that in the coming days. The strings are so amazing. We can do so much on strings, but we need to move on to look at booleans. Okay, booleans. Why is my boolean? No, it's not here. Okay, so okay. So basically, we've looked at booleans, and booleans, as we spoke about, were true and false. So boolean only has 2 values, which is true or false. Okay, but it is not that easy. Okay, with booleans, for example, if I can typecast a value to a boolean. Okay, so if I type, let's say, true here as a container, this is actually different from this. Okay, in Python. The one with the small letter is a variable. The one with the capital letter is a constant. Okay, so print true here will tell me it's true. Okay, if let me click this here, let me run this, and it tells me it's true. Okay, but what if I typecast 1, okay, like this to Boolean? If I do this, it will tell me it's true. What if I typecast co like this? Co will still be true. So in Python, anything that is not an empty string or 0 is true. If I put an empty string in here, it will tell me it's false. Do you see that? If I put 0 in here, it will tell me it's false. And Booleans are so important in Python because they can be used in making decisions. Okay? Every decision that you make gives you an output of either true or false. Okay, and we're going to see that here in a second. So in Boolean, we have only true or false. But if you pass a list here, it will not be false. It will not, an empty list will give you false. But if you create something in here, like car, it should give you true. Okay, the same thing can be said for tuples and dictionaries and so on. So it is important that you note this. Okay, so the next thing we're going to look at is decisions. Okay, decisions. But before we look at decisions, we're going to look at some comparison operators. We're just going to look at 6 of them. Okay, so there is the equal to. Now, do you see this one right here is different from the assignment operator? There is the not equal to, okay? There is the greater than, there is the less than. Sorry if I can find this on keyboard. There is the greater than or equal to, and then there is the less than or equal to, okay? So basically, in Python, whenever you are making decisions, you use the keyword if, okay? If. So if I want to check if 3 is equal to 3, okay, then this is how I go about it. But it comes a bit weird, okay? You need to put a colon here after your statement. Press enter, and then you now manage what we call the indentation. Okay, so if I'm checking if 3 is equal to 3, then I want to print hooray, okay? Hooray. So if I run this script now, and I'm going to clear my screen, my console first. If I run this script now, it tells me hooray, because yes, 3 is equal to 3. But let's make this a bit much better, okay? So let's do num1 and say 3, and let's do num2 and say 3 here. So now we can compare num1 to num2, okay, like this. If we run this script, we still get the same answer as hooray. Now, what if I change num2 to 5? Sorry, to 5. Is 3 equal to 5? Amira, is 3 equal to 5?
No, 3 is not equal to 5.
So the answer is false, right?
Yes.
So it's a Boolean. So the output of every comparison is a Boolean. You either get true or false, not no or yes. It's true or false. So is num1 equal to num2 is false. So if that is the case, this will not execute. If I run the script, I see nothing is printed in here. Okay, I'm going to collect the screen again. I'm going to run this again. You see nothing is printed in here. So if it's false, then Python gives you an else part, okay, like this, which you can say, let's say, tada, here, okay? So the else part in your decision is whenever this comparison that you are making results to a false. So num1 is not equal to num2. The answer is false, so we get tada. So if I print this, I get tada, right? But if I change this 5 to 3 and I do this comparison, I'll get hooray. So you see how easy it is and how convenient it is. But can I just use equal to? No, I can even use not equal to, okay? So is num1 not equal to num2? What do you think will be the answer? Philip, num1, is it not equal to num2? Hi, Philip. Prudence. Hi, Prudence. All right. So let's just, yes. So num1, okay, Adrian, I think we already answered it, so maybe the next question. Okay,
Hi.
so num1 is 3, num2 is 3. So num1 and 2 are equal. So if I say num1 is not equal to num3, num2, it is false. So we get tada here. What if we use the greater than symbol, right? Is num1 greater than the num2? In this case, it will be false, so we still get tada. But if I change num1 to 5, then num1 becomes greater than num2, right? So we get hooray. So that is how you make decisions in Python. You use the if statement. But sometimes you want to make multiple decisions, right? So maybe we also want to check else if, right? Num2 is equal to, is greater than or equal to, or let's just use equal to num3, okay? Then do let's go like this. Let's go like this, right? So now we need to declare num3 here, create a container, and then give it, let's say 8. So if we run this code, num1 is greater than num2, so we get hooray. But num2 is not equal to num3, so these ones will not run, right? So let's clear our console. Let's run the scripts. And now we get hooray. So now what if we change num3 to 3 as well, and we run this? Then what do we get? We get only hooray. Now, what is happening here is that when you are doing this staircase if-else statement, right? It only checks the first one. If the first one passes, it would not check the second and the third one. You can have any number of else if statements in here, okay? So I can have another else if like this, num1 is less than num3 like this. Then we can print, come on, okay? If only one of these is correct, only that block would be executed. Hi, Shima.
I have a question.
Please ask.
How will the compiler know that the if condition? How will it know that the block is over, or is the block line of if statement is over, like an end if? How will the compiler know it?
So you see, in Python we use indentations, right? So when you indent a code here, it's referred to as a block.
Yeah.
So for example, if I put another code here like this, print, and I say Shima, right? This everything in this indentation is a block. So everything in this indentation will be executed until it gets to the last line of code.
Okay.
Do you understand? So if I run this script now, you see hooray and Shima. You see? But now if I should change this to -5, -5, and then I run this script now, you get let's go. Because the first condition would fail, but the second condition would pass. So it would execute the block in the indentation and then ignore the rest. Okay. Do you understand? Yeah, so it is important for you to actually appreciate how you can make decisions in Python.
Yeah.
Okay, great. Now, there's also other operators that you can use in making decisions, and one of which is the logical operators, okay? So now, in the logical operators, we have AND, we have OR, and then we have NOT, okay? Now, the logical operators basically allows us to actually check multiple things at the same time. So let's close this here. So if I want to say if num1 is less than num2, okay, and num2, actually, let's see, num2 is equal to num3, then print this, print writes, okay, like this. The end here is a logical operator. It allows me to be able to make multiple logic or multiple comparisons. So I'm checking this first. This will result to either a true or a false. Then it will check this one as well. This will either result to a true or false. This block will only execute if this and this are both true. Okay, so now look at this. I'm going to put my else block at the end here. Else, not that, else, I'm going to put print left, okay? so left. So if I clear my console and I execute this, okay, I get right. Why? Because -5 is actually less than 3, and 3 is equal to 3. Now, in an event where I change 3 to 4, then this condition, this part will be false because num2 will no longer be equal to num3. So I would get left as my answer. Do you see that? So the logical end checks if both conditions are true, then the output will be true. Anything else will be false. Alternatively, we can put or here, okay? For the or, even if one of the condition is true, the output for both will be true. So this block will be executed. It will only be false when both of them are false. So if I execute this, I would get right. So now this takes some practicing and some getting used to, okay? So you need to actually get used to it. I can also use the not here, and then let's say not, and then the not is actually going to convert whatever this answer is to true, okay? So if I execute this, I'm going to get right. If I change this to end, okay, and I execute this, I'm still going to get right because the answer will still be the same. Sorry, where are you? -5 is less than 3, and 3 is not equal to 4, which is false. So not to make it true. So both of them become true. So we get right. Okay. Great. Then there's the identity operator. Okay. There is the identity operator. So for the identity operator, it allows us to be able to check if something is equal to something, right? So for example, if I have, let's say, if I have two objects, all right, or let's say list, okay, let's say call this class, okay. Let's use strings, okay. Let's use name1 and say Paul, yeah. And then use name2 and call this John here, okay. If I say name1 print name1 s name2, what do you think the answer would be? Right? It is going to compare these two. So let's clear our console and then let's run this. It's going to tell me it's false. But now let's put code here as well, and then let's execute this. Now it's telling me it's true because code is the same as code, right? So it compares the content for you, right? You can use the second one is not, name is not, name1 is not name2, and then this will give me false because it actually is. But if I should put John here again, then it will give me true, right? Because Cole is not John. Do you understand? So it's just like English, and we're going to do a bit much more on this as and when we are doing practicals, right? Great. The last but one is the membership operator, which we have already looked at. So is the in and the not in. Oh, sorry. I didn't put the S and not S. Sorry, it's not. It's not here. Then we have the in and then not in. Okay, not in. So the in basically checks if something exists in something. So for example, can check if C is in name1, right? Sorry, name1. If C is in name1, I would have a true. And you can see that all these things are, the answers that we're getting are all Booleans, right? They are all Booleans. So name1 is in, C is in name1. But if I say C is not in name1, then what do you think I get? I get false because C is in name1. All right. Great. So basically, we have looked at decisions. Making decisions in Python is basically you understanding the comparison. What are you making the decision on? Are you comparing two things? Are you comparing three things? Do you understand? Are you comparing four things? Whatever decision that you are making will be a comparison. Are you checking if is something equal to something? Is something in something? Okay, hi Kenneth. Hi, Kenneth.
Yeah, can you hear me?
I can hear you now.
All right. Okay. So my concern is why use the identity operator when you can use the equals operator? Won't they give the same answer?
So okay, there's someone. Wait, is it your background? Oh, okay, I think it's yours. So yeah. So Kenneth, your question is why do we have multiple options to doing our comparisons, right? And my answer.
Why do we have use, or in which cases are we to use the identity operator instead of
so that is what I've given you a classical example here, right? Especially if you are comparing numbers, right? Use the double equal to. Okay, but if you want to compare in terms of objects, you see, I don't want to talk so much about the identity operator because we've not discussed objects. Okay, but if you are comparing in terms of the objects, it's good to use the identity operator. But as we proceed in the program, I am going to give you some examples that you would see the practical use of these ones. Okay. Okay, good. Oh, my neck. All right. So yes, last but not the least is the pass keyword. Basically, if you write a conditional statement is num1 greater than num2, right? You cannot just leave it as this and then go write something else. You keep getting an error, you see? So you can easily put a pass here, and it basically tells Python that, hey, I've not yet defined whatever will go in here. So please pass on this so that I can do whatever I want to do. So I can go on here to actually declare num4 and then assign it to 89 and so on without me getting an error. You cannot leave an empty if statement like this, or an empty else statement, or an empty if else statement. You always have to define it. So the pass keyword allows you to actually hold on until you are ready to come define whatever is in here without you getting an error in Python. Okay. Great. I wanted us to touch on the for loop, but I guess we'll do that in our next session. So we'll move to functions. But before we do functions, do we have any questions on these? Hi, Victor.
Hi, cool. Listen, can we go to the strings? I have a question for.
Where? String. Okay.
Replace.
Replace. Okay.
Okay, assuming we have a variable like a living thing as a variable, and we declare the variable to be. Assume we have a variable living thing.
Living thing, right? Like this.
Declare it to be animal.
Animal. Okay.
I want to replace. No, let's use small letter. Let's use lowercase for everything.
Okay.
I want to replace A in the animal. How do we do it? How do we tell the program to replace the?
You want to replace A with what?
A at the position 1, 2, 3, 4, 5. Position 5, not the first position. So how do we do it?
Okay. So you want, so you have multiple A's in there, right?
So
you see, so look at this. When you hover on, if you're using VS Code, right? When you hover on the replace, you see this is the template, right? Do you see what I see on my screen? So you have the old, you have the new, and then you have what? The count. So the supported index. So you can pass another argument, which will be what? The support index. Do you see that?
Okay.
Do you see that? This
yes, I can see. I can see.
Yes, good. So basically what you do is so for example, right, returns a copy with all occurrence of a substring old replaced by new. Now the count, maximum number of occurrences to replace. -1, the default value means replace all occurrences. So if the count here, you can just put which one you want it to replace, right? So you basically need to look at the schema of that particular method to understand what you want it to do. Do you understand? But I think it's a very good question, and it's something that I would want you to actually explore on. You see, it's not everything that you would want to ask. Okay, so some things you need to research. Okay, good. So now I'm going to execute this here. So now you see it replaced all the A's with what? Star, right? Now, if I put count here and I put 1, right? Execute this. Then you see it replaced the first one.
Okay.
Okay. So so what if you put 2 here? What happens, right? It replaced 2, right? So basically, you just need to put the supporting index to actually identify whichever one that you want it to replace. Okay, but it will be better for you to actually explore the documentation to see further what the replace function does. Okay.
All right, thank you.
All right. Oh, good. All right. So the last thing that I want us to do here is functions, right? Now, we will go beyond our time a bit, so please spare me on that, forgive me on that. But it is important that we do functions, because if you don't do functions, you are going to have some challenges in your on the task on the intranet. So please bear with me here. So all through this time, we have looked at how we can write basic programs in Python. We've looked at how we can replace tests. We could look at how we can convert tests. We can look at how we can perform operations, casting, make decisions, and so on. Each and every single line of code that you see here is a software, okay? It's actually a program. Every single line of code that you write here is a program. It is these instructions that come together to form a holistic part of the software that you are designing, okay? So what is a function? A function is basically a block of code that actually performs an operation or returns a value. Okay. Now, not every function will return a value, but a function is designed to actually perform an operation. Okay. A function is designed to perform an operation. So it's a block of code designed to perform a specific action or return a value. Now, there are a couple of things that you need to understand about a function, right? Why do we need functions? Functions basically allows us to actually break down our code into smaller chunks. Okay, smaller chunks. For example, if you come in here into our code here, we have a bunch of code here. Assuming that I'm going to uncomment all these things here. Where's the other one? Blah, blah, blah. Oh, did I remove that? Okay. Assuming that I have all these things here, and I clear console and I execute this, I'm going to get all these answers, right? These are all a bunch of instructions that I need to execute, but maybe sometimes I only want to execute one based on a particular condition or based on a particular purpose or a particular event that even happens in the program, okay? Functions are a way that helps us to actually break down our complex program into smaller programs. Okay, so to write a function, it is quite easy in Python. Remember the way we made our decisions in Python? We use a keyword known as the if statement, place the space, put our condition, and then a colon. Then we specified the block of code. That is the same thing can be said for a function, okay? So if I want to define a function, I use the define keyword, the def keyword, and then I use the name, I give that function a name. So say hello, then I use this parenthesis, then followed by a colon. Once I do this, I have defined a function, but I need to tell the function what at all would this function do. I want this function to basically print or say hello world, okay? Now, in here, what you can see is essentially I have defined a function. I have created a smaller program, and I'm saying this program would be called say hello. This program would never be executed until I call that function. So I can call this function by using its name, say hello, like this, okay? And now when I execute the program, it would say hello. Now, what happens if I don't call this function? Let's clear this here. And then run. It tells me what did I just do? Okay, sorry. So clear, okay. So when I run this function, when I run this script, the function has been defined, but you realize the code was not executed. Guys, I want you to pay attention to something here. In the decisions file, as soon as I run this script, everything executes. But see, functions are giving me the opportunity to be able to tell my script when to actually execute some code or not. Okay, this is not a decision. Okay, so by grouping my code into functions, I am able to actually call the function as and when. So I can define another function here, and this function is going to add two numbers, right? Add numbers. Okay, and then in this add numbers, it is just going to add print 45 plus 90. Okay, these are two different blocks of code. This code here on line 8 will never execute until I invoke or call that function. Okay, so when I run this script, I only get hello world because hello world is the only script that I have called. You see? And how do I call the function? I call the function by its name. Okay, I call the function by its name. You see that? Good. So if I want to get the add number, that is adding these two numbers, then I have to call this function add number. And then I'm just going to comment. Let's just leave that one there as well. So now I have called both functions. So if I execute my script, I get what? Hello world and then 135, which is what? Adding these two numbers. Now, functions are not designed just to have only one line of code. So let's have a function here that check voting privilege, okay? So it checks if people can vote. So it will take as a parameter the person's age. Okay, then we're going to say if the person's age is greater than or equal to 18, then print hello, then your name, let's put Cole here. Congratulations. Comma, you can vote, okay? You can vote like this. But what if I cannot vote, or what if the person can't vote? Then we want to print, sorry, you can't vote, okay? Like this. So you see, this function here is quite different from this. This function is taking something weird here, which we call the parameter, okay? So this parameter, whenever I'm invoking or calling this function, check privilege, okay, I need to give that function my age. So if I say I'm 12 years, then this function would now execute this block of code that exists inside of this function, okay? So now if I execute this, it tells me, sorry, you can't vote. But what if I pass 18 to it, like this? Okay, then it tells me, hello, Cole, congratulations, you can vote. Right? So the function can be written, can have any number of lines, right? But if you follow the best practices, you can only contain a few lines. The function has to be straight, it has to be precise, it has to do what is expected of it, and so on. You don't have to put everything in your function. It wouldn't make sense. And I'll show you that in our next session. Okay, great. So this is how you write a function in Python. But let's take it one more step, okay? Now, this time I want to also add my name, okay? And then instead of printing code here, I actually want to put my name here. Put whoever's name here, okay? So we're going to use format, and we're going to put name here. Okay, so now this will now accept a second argument, which will be Johnson, okay? So if I run this script again, now it tells me, hello, Johnson, congratulations, you can vote. Now let's make it a bit more dynamic, okay? So I'm just going to come here, I'm going to say name, and I'm going to say inputs, enter your name, okay? And then I'm going to put age here, and we'll say how old are you? Okay. So now in here, instead of passing 18 and Johnson, I'm going to pass age, and then I'm going to pass name here. Okay. Sorry. Now, what have I done? It is quite simple, but I need you to pay close attention. So I'm going to clear my console and I'm going to execute the script again. I'm going to type my name as Shima. Shima, hold on a second. And I'm going to put your age as, let's say, 78. Now, you see, there's a problem here. It's checking if age is greater than 18. But now, it's trying to check. It's telling me greater than or equal to is not supported between instance of string and end. So what is happening here? Right? Because we remember from typecasting that this particular input field is going to return a string to this. So we actually need to typecast this input to an integer to perform the comparison. Okay, so let's do this. Let's clear our console, execute again. Let's put Johnson. Okay, Josh, and then let's put 78. So now we get our answer. Okay, now what if we don't do that? Okay, now for now, let's keep it here. I was going to use the identity operator, but it's fine. Hi, Shima.
Hello.
Hi, Shima.
When do functions act like loops?
When do functions act like loops?
Yeah,
so
because
there's some
program,
there's something
that I tried to write, and there were no like for or another loop, but it looped itself, or it made the repetition. Why?
Yeah. So it is called recursion. Okay, it's called recursion. So a function that calls itself is called recursion, and we're going to look at that particular concept in the coming days. It's quite complex, so you need to understand these basic ones before we get to recursion. Is that okay?
All right. Okay.
All right. Hi, Adrian.
Good.
Hi.
Are we limited to the number of variables we can put in the parameters of the function?
No, you are not, but there are best practices that you need to follow. Okay. So you can pass any number of arguments, parameters to it. Okay. But imagine if I had about 20 parameters here, my code would be very dirty, right? Hi, Adrian.
Yes, it would be there.
So it will be very dirty. So imagine if you are writing a program that requires more than 7 parameters, you need to break that into 2 functions. You're not going to use all those parameters in the code. Your function will be too bulky. As I said, as we go along in the program, I will explain all those best practices to you.
And cool, one more thing. If the name and the age were on top of the function, will it still run? If
like
both name
like this one here. If I bring this one here,
on top of the function,
yes, it would. So you see, I always say it is always good, Adrian. It is always good that you try these things out when you see them. Okay. When you try them out, it's only when you try these things out that you actually understand the intricacies of the program. Okay. So now I just showed you. So next time you just try it yourself. Okay.
Yes. Thank you.
Okay. Good. All right. Any other question? Good. So you see me doing a couple of things here, right? You see me defining a function. You see the way I have defined the function. It's a simple function, right? That is just checking if you can vote and printing your name. Now, what if, so the number of arguments, right? So what if I want to say, oh, you know what? I made a mistake. I want to put name first, yeah? And then, and then age here, okay? Maybe that is the order that I want. If I do this and I run the script, I'll first of all clear my console, I run the script. It would run as anticipated, but I'll run into some problems. So let's see. You see, I'll run into some problems. But there's something called a keyword argument, okay? So you can actually use the name. So now, you see what I've done here? So I'm going to clear the console. I'm going to run the script again with Josh, and then 89. So now you see it works as expected. This is what we call the named or the keyword argument. So sometimes in Python, it does not matter the order in which you pass your argument, so long as you put the name of the variable that you place as a parameter. Okay, so in here, I could have said this is username, and I can say this is user age, like this, right? Then instead of name here, I put username, and then here I put user age. So clearly, you see these are two different variables. This one here represents the name that I gave to the parameter at the time of creating this function. And then this one here represents the variable that I have created in the script. Okay, so these are named arguments. Okay, now there's something here that I want to discuss with you guys, which is parameters versus arguments. You keep hearing me saying parameters, argument, parameters, argument. What is the main difference? When you are defining a function and then you create these variables here, these are known as parameters. But when you invoke or call the function and you pass the actual values to this function, it's called an argument. It's as simple as that, okay? No need for you to worry yourself. It's as simple as that. Any questions up until this point before I go to the next part? All right, so if there are no questions, then what did I say the function, the definition of a function was? Who remembers? Who remembers what I said the name of a function was? The definition of a function was, sorry. So okay, hi Shima.
Yeah, you say that a function is like a container or a big block of statements which contain some statements to be called or invoked, after which enables us to simplify the programming codes.
Amazing, amazing, amazing. But I also said that apart from it being all of what you said is a function is a block of code that performs an operation or returns a value. Okay, it can return a value. Hi, Simelo.
Hello,
Code. Hi.
You also said it can be used to break down code into smaller chunks.
Exactly. So we can have multiple parts of our code written in different functions. So we can be like, we have a big chunk of code here, right? And this code here, we have a function that checks if the user can vote. Then we can also have another function, okay, vote for candidates, okay, like this. Okay, so this function here is actually going to allow us to vote for the candidate. Then we can have another function that counts candidate votes, right? Candidate votes, okay, like this. Okay, so now you realize that by doing this, we have broken our big code into different chunks. But one thing that we also need to understand is functions do not only just perform operations, they can perform an operation and return a value. Okay, so for example, I can have a function here that adds some numbers. Okay, let's call this numbers. Okay, now these numbers can be number 1, number 2, and number 3. Okay, this function can be written to add. So let's have sum here, which will be number 1 plus number 2 plus number 3. Okay, now we can say print sum, and then this would work. So in this case, the function is going to perform an operation. That operation will be to add these 3 numbers, okay, and then print the sum. So if I invoke this function like this, add numbers, okay, and I pass 45, 12, and then 10, what will happen is, and I'm going to comment this function out, and then yeah, that's all. Okay, if I should execute the script, you see why it's asking me to enter my, oh, sorry, I should have commented this one out. So you see one reason why we need to use functions. if I had grouped this into a function itself, I wouldn't have had to comment this out. So for now, I'll just comment this out. I'll execute this and then run the script again. Okay, so now you see I get 67 here. It has performed an operation, but it did not return any value. We can actually modify this function, add numbers. Okay, numbers, and tell it to actually add these numbers, let's call this 2. Oh no, let's make this add 3 numbers, okay, like this. Then we do num2 and then num3, okay. We can add this to return an integer, and then we can return num1 plus num2 plus num3. Okay, let's just take this out for now. Okay, so the return keyword here is basically going to say, you know what, add all these things and then return the answer. You realize it is not going to print. Okay, let's use the same approach that we used here. Sum, okay, add all these numbers here, store the answer in sum, and then return that sum. Okay, now if we use this same approach here, you would realize it will perform the computation, but will get no answer. You see here, that is because it has performed the operation and returned the value, but you are not doing anything with it. So I can create another variable here, sorry. I can create another variable here like this. Now, whatever I'm returning from this function will be stored in this container. Okay, and then now I can print num like this. Run the script, and now I have my 67 back. It is important for you to note the differences between writing a function like this, right, that performs the operation and does not return any value, and a function that you define, you declare, but you have not defined yet. So you use the pass keyword to tell it to hold on. Then you also declare a function, you define the operations, but you don't return anything. And then you can also declare and define a function and then return something from it. Okay, so any questions here? Any questions here? So the last bit of this is I'm going to open one of the tasks on the intranet, and I'm going to show you how you are supposed to go about that task. Okay, those tasks. Okay. So I'll choose the most simplest one, okay, which will be the task 0 of functions. So I'm going to bring you here. And I'm going to bring this one out here, okay? So with all what we've learned, I want us to put this into perspective, okay? And then see how we can actually solve some of these questions. So with task 0, see what happens here. So I'm going to close all these, I'm going to close all that. In this project test file, I am going to create a directory called, a file called 0-sum, okay? So I come here and I'll create this. Now, in this 0-sum, I've been tasked to write a function that adds 2 integers and returns a result. So I'm going to define my function, and then we also say your prototype should look like this. So define add, that takes 2 parameters, A and B, okay? And then it's going to what? Return what? The value A plus B. So I'm going to return A plus B, okay? So what has happened here is that I have actually defined my function, and then I'm returning a value from it. But I also want you to understand how you can test these functions. So in the code fragment that you see here, you can see this line of code here, okay? So I'm going to create this file, 0-main, in this same folder. Then all I'm going to do is copy this line of code in here. I already include a guillaume here. I'll copy from this side up to this, and I'll paste it in here. That is all I need to do. Okay, so now if I want to test to see the function that I have defined here, okay, I've defined in the 0-sum, would it give me the same output that I'm seeing here? Yes, it should. So this is the file that I need to execute, which is my main file. I'll click on this, but I want to explain this to you. You don't need to understand what this is doing, okay? But essentially, I am bringing whatever your file, 0-sum, you can see the name here. And whatever function that you have in here, is the same name is in here, right? I'm storing that value in here, and then now I'm passing or testing with some values. Okay, so now if I execute this script, yeah, you see I should get 398.98. 398.98. This is the same answer that you get here. So this shows that I have solved this question and I have the answer. Any questions up until this point? Any questions up until this point? Right. So whatever code that you write in here, we have given you test cases, right? So the way you test for it is you just create this file, okay? And then once you create that file, you just copy this code in here and then paste it in that file, run it, and it should, if you design the function properly according to the requirements, it should actually give you an answer. Okay, so you can do the same thing for all of them. Okay, all of them. Maybe we should even do, we can even do this, but okay. All right. Any questions up until this point, guys? Any questions up until this point? All right, guys. So I guess everybody understands. Thank you so much for joining the session. Hi, Fortune. Fortune, are you here?
Yes, I'm here. Hi.
How's it going?
Good, man. Good. I joined late today because I was caught up in meetings. But yeah, I was just trying to make notes and make sense of all the concepts that you were explaining. Seems a bit dark for now, but hopefully as I do more practice, I'll get a hang of it.
Okay, so you see the approach that I used in this session. So if you go through the video, follow it step by step, you should understand everything that I've done. Okay,
absolutely. Yeah.
Whatever task you're seeing on the intranet is just a collection of whatever that we've done here. Everything that we've done here has been put together as a task.
Right.
And remember, every task on the intranet is a problem that we want you to solve. Okay, so for example, if you look at this task, it says write a Python function called validate password. And every one of us here has logged into something before, right? So when you are logging into something, your password is being validated. So we are training you on how you can write something like that. But I'm not going to give you the answer. Okay, so it's telling you that it takes a password as an input and perform the following checks. The first check is that the password should be at least 8 characters long. So we've done this. We've done this in strings, right? How do we check for the length of a string? I think from last week, we did that. Then the password should contain at least 1 uppercase letter, 1 lowercase letter, and 1 digit. I already showed you how you can access other methods on strings. We did a few of them, which was the replace, was the capitalize, was the count, was the split, it was the upper, was the lower. There are so many of them. Okay, so you need to actually go through them and then see all of them. Then the password should not contain spaces. So you remember how we checked if there was a space, and that answers one person's question, the S, right? The identity keyword, right? You can use all those ones, the identity, the in, and so on, right? You can check all those ones. Now, by understanding and being able to design this, you've built your first program that validates a password. Okay, so this is how your prototype will look like, and it should return true if the password passes all the checks and false otherwise. You see, every single task that you have on the intranet is a testament of what you've learned. It's a test of what you've learned. Okay, so write a function, Python function called is prime that checks if a number as input returns true if the number is prime. Basically, it is a combination of everything that I've taught you here. But the problem is you want to check if a number is prime. So how can you put everything that I've taught you in here to write that program? Okay, there's another one here that checks if it's a Fibonacci sequence or not. Okay, so that is how this session has been.
Okay.
All right. North. Hi, North. Hi, North. Are you still here?
Yes, I'm with you. Can you hear me?
Yeah, I can hear you now.
Go ahead. I'm listening.
Is there anything that you need clarification on, or do you believe you've received enough fundamentals to tackle the project on the internet?
Cool. You did a great job. Well, in class you feel very confident until you face it in real life. Then you realize that, man, there's still a little bit of gaps. But now I feel confident.
Thank you. Yeah, thank you so much, Not, for saying that. So what I want to add on to that, Not, what you just said is this. This is not a class, okay? This is reality. Whatever you are seeing here, it's whatever you can write to make money from. Why are we here? No, I don't believe there's anyone on this call who wants to just write code and then just give it out to people. So don't look at it as a class, but look at it as practicals. So before you attempt those questions, and I wanted us to solve these questions, right? Before you attempt those questions on the internet, go online and find questions, okay? Or check, think of some questions that you think that you can solve using Python, and then try solving them. If you have any complications, you have me at your disposal. Send me a message on Discord. Cool, I'm trying to solve this problem. This is the code that I have written. It is not giving me the desired output. What do you think I'm doing wrong, and how can I correct this code? Trust me, I'll be more than happy to analyze that code or review the code and tell you this is what you're doing wrong, or this is how you can go about it. If you use that approach, it is not going to be a classroom approach. It's going to be a practical approach, okay? If it's a practical approach, then everything that you see on the internet will be a test of your knowledge, okay? All right. Hi, Henry.
Cool. Do we get access to this your Visual Studio Code or just the video?
Yeah, so you have access to the video. You have access to the video because it's on the intranet, okay? So you can see the video, but if you want the content, okay, I can share the content on I'll put it on GitHub and then share it with you on Discord.
Sure, okay. Thank you.
All right. Hi, Amira. You are muted, Amira.
Sorry, hello. I have a question in the Hello World project.
Okay.
The third one, the last digit. My code is passes. It says that it's correct output for positive and negative and 0, but it says that there is the correct output wrong type. It doesn't pass. So I don't know what's the problem with that.
Is it the first one here? Oh, sorry. Which one is it? This one
number
here, right?
3, the one that's called the last digit. Yes.
Okay, so let's check this. So I'm going to put your name here, Amira. So let's test your code, okay?
Okay.
Is this you?
No, Amira Al-Gohari, A-L-G-H.
Oh, okay.
Yes, Amira Al-Gohari.
Okay, so I'm going to show you this here. So you are trying to solve a problem, right? So now you pass for all of these, but you're not passing for this.
Yes, I don't know.
You see, first of all, the error is telling you that there's a value error. Okay.
Okay.
So let's go to your code. Okay. So I'll go to Hello World and I'll go to what is it? Last
digit, number 3. Yes.
Okay, good. So I'm going to change this here. This code. Okay, so give it a second. So let's look at your code and see what is going wrong. So so you see I have VS Code on GitHub, right? So you can do that by just changing your .com to .dev, and it's going to give you a GitHub. Okay. So Amira, you see here?
Yeah.
It's giving you a value error, right? If you look at the error that we have here, it says it's a value error. It's expecting a type error. So the first thing that I would do if I was you is to check what is the difference between a value error and a type error.
Yeah.
Okay. Now, if you look at your code here, you've imported random, okay, which is okay. And then whatever number that you have here, you're converting it to a string. So you're typecasting it, right? And then in here, you are getting what? The last number. Okay?
Yeah.
And then putting it here. Then once you have that last number, I like the way you're solving it. You're converting it back to an integer. Okay? And then you are checking if that integer, that last digit here, is greater than 5, if it's equal to 0, or if it's less than this. But look at something that you're doing here. In here, you are checking if the number is less than 0, okay? Then you want to set last digit to what? A negative.
To negative, yeah.
But Amira, if you do this, you are only checking the last digits from the top here.
Okay.
Do you get it? You are checking the last digit before you are resetting this. So this operation will never happen. One way you can do this, it will be to put this on here. Okay. So what you do is you first of all check if the number that was generated was a negative number, and then set that negative number here before you perform this operation.
Sorry, I don't get it. I should change.
Okay. No, I'm not. I'm just giving you a suggestion. I'm not solving the problem for you.
Okay. Yeah, I understand
so,
now. Okay.
So see your script, right? In your script, line 7 and 8 here is actually getting the last digit. This will only happen if it's a positive number. Okay?
Yeah.
So your code will only work for positive numbers. Now, when it gets to the negative number, you're trying to do the negative number here, but that will not work. Because when the number is 0, is a negative here, you are changing the last digit to a negative. It won't work. Okay, so you have to rethink what's your solution a bit. Okay.
Thanks
all right.
a lot.
Okay, you're welcome. I think. All right. So just take a look at that, and then let's see what happens. All right, guys. Thank you. Oh, all right, Shima.
Yeah, I have a problem.
Okay.
Yeah, I have a problem on the Python Hello World.
Okay.
Yeah, the first project or the second one. I don't really remember. Let's see the second one.
This one here.
Yeah, the second. Yeah, that one. Okay.
Okay.
They say to print. Okay.
Shima, is this you? Shima Derek?
Oh no, Shima Remy.
Shima Remy. Okay. Very sorry. Oh, can you give me your email?
Remy Shema. Remy Shema 20.
20. That's all.
gmail.com.
Yeah, that's fine.
Yeah.
I just need Remy Shema.
Yeah.
Okay. So, so first of all, look at this.
Okay.
Your output is getting 61 characters, but we want 58 characters.
Okay.
You see that?
Yeah, I see that.
Then the first thing is the first 3 letters should give you whole, but the first 3 letters that we're expecting is school, SHC.
Okay.
Okay. Now the second, the last 2 letters is ON. That is what we are getting from you, but the last 2 letters should be OL. Then the middle letter yours is Obelton, but the middle letter should be Cho. So let me show you why.
Okay.
I'm going to open your code. And then I'll come here. Wait, is it one? Yeah. So you see in here, first of all, if you look at the question, right?
Okay.
The question says, you can find the source code here, right? So you can open the source code here. You see? So now this source code here is solving a particular problem, right? You are not allowed to use any loops or conditional statements. So you are supposed to complete this code here, right? So you're supposed to complete that code here. So your code goes here, right? And this should be the output. So whatever your code is in here, your code has to be there. So you have that one here. Okay, so it says your program should be exactly 8 lines. Should contain the first thing. Okay, so you know the time is almost up. So as passed, and I have to join another meeting. So Shima, send me a message on Discord. Let's look into this. Okay.
All right.
I need to join one very important meeting.
Okay, I will do that. Okay.
All right, guys. All right. Thank you so much, guys, for joining this session. It's been an informative session. I hope you've enjoyed it as much as I have. It's been quite practical. And next week, we are going to go even further. But we have a special session tomorrow, okay? Tomorrow, we're going to have a live coding session on cloning a particular website. So we're going to do HTML, CSS, and then we'll see how we can actually put these things together. If you're having any challenges whatsoever with HTML and CSS, please join tomorrow's session so we can do it together. Okay. As well, be sure to complete all the projects released this week. If you're having any challenges, please do not hesitate to reach out to your colleagues, your peers. Do not hesitate to ask questions on Discord, as we are ever ready to answer all those questions. And don't hesitate to reach out to me if you have any challenges. I am more than happy to assist you. We'll join a one-on-one call. I'll walk you through the solution, the problem. I'll help you derive the solution and make life so much easier for you. Thank you all, and I'll say